Okay, welcome back. Now we're going to do a couple of application type examples. Okay, so the first one is we're given this function and they want us to find all the points where the tangent line is horizontal. Okay, so we have to kind of do some critical thinking here because we have to understand what it means to be a tangent line that's horizontal. Okay, and how we find it. Okay, so again, remember tangent lines, when we talk about tangent lines, we're talking about derivatives, right? So the derivative gives us the slope of the tangent line. Okay, and then of course the tangent line, if it's horizontal, then we know that the slope of any horizontal line is 0. So what we're doing is we need to take the derivative function, and then what we need to do is we need to set this function equal to 0 because we want to find all of the values of x where the slope is 0, and at those points, at those x values, will be the points that we're looking for. Okay, so let's do that. So the first thing is we got to take the derivative, so find the derivative function. So f prime of x is going to equal what? It's going to be 3x squared, right? Minus, so this is the constant, so again it's going to be 2x, but 2 times 7 is 14, so we're going to have 14x. Then of course with this we're going to have 8 times the derivative of x, which is 1, so this is going to end up being 8. And then of course the constant goes away because the derivative of any constant is 0. And so this is our derivative function. Now we want to find all of the x values where this function is equal to 0. Okay, so now what do? Well, now we got to factor this thing, right? Or we're going to have to use the quadratic formula. So, but let's see if it's factorable. Okay, so let's use the method of decomposition or the AC rule. So 3 times 8 is 24. So we need 2 factors of 24 that add up to negative 14. Well, since this is positive, we know that they both have to be negative since this is negative. So we got 2 negative factors that multiply to 24 but add up to 14. And so what would those 2 be? Well, that would be, let's see, 24, well, 2 times 12. Yep, so 2 times 12. So that's going to give us what? It's going to be x minus 2 times x, oops, I'm sorry. That's going to give us 3x squared minus 2x minus 12x plus 8, right? We decompose the middle. And now we're going to do factor by grouping. So what is that going to give us? That's going to give us what? We're going to group these two, and I'm going to change this to a plus negative, right? Just to make sure I don't make any sign errors. And so this is going to give me this, and now I'm going to factor out the greatest common factor here, which is going to be x. So we get x times 3x minus 2, plus, now I'm going to factor out a negative 4. So negative 4 times 3x minus 2. And so now I factor again, because now I've got another common factor, and I get 3x minus 2 times what's left over, which is x minus 4, and there's my factoring. So now I know that the 2x values are going to be what? It's going to be x equal to 2/3 and x equal to 4. And those are where the 2 horizontal lines are located. And if I wanted a point, if I wanted the actual point where they're located, I would just plug in the x values into the original function. Okay? Not into the derivative function. Okay? We use the derivative function to find the x values where the tangent line is 0, but then to find the point, we go back to the original function and plug in. And that's it. Okay, so now, the second problem is a velocity problem. And in this problem, they give us the position function of s of x, or excuse me, s of t, so related to time, s of t is equal to t divided by the quantity t squared plus 1. And they want to know, hey, given this position function of a particle moving along the coordinate axis, what would the initial velocity be? Okay, so the key thing is we're looking for initial velocity, which means when t equals 0. Okay, so again, but how do we find velocity? Velocity, instantaneous velocity, right, is equal to the derivative of the position function. Okay, well, how are we going to do that? Well, we're going to use the quotient rule. So this is going to be what? Low d high, so it's going to be t times the derivative of the bottom, which is going to be 2t minus, oh, wrong one. I did it wrong. Low d high, which is t squared plus 1 times the derivative of the top, which is just 1, minus high times the derivative of the bottom, which is 2t. Okay? So low d high minus high d low over low squared, which is t squared plus 1 quantity squared. Okay, now I'm just going to simplify the numerator. And so this is going to give me what? T squared right? T squared plus 1 minus 2 t squared over t squared plus 1 quantity squared. And so now I can subtract these two. So it's t squared plus or minus 2t squared is going to give me 1 minus t squared over t squared plus 1. Okay? So now this is the function for instantaneous velocity. So now I want the initial velocity. So that's when t is equal to 0. So now what I'm going to do is to find t of 0, right? So I want v of 0. That's the initial velocity. So that's going to equal to what? It's going to be 1 plus 0 squared, which is 0, over 0 squared plus, minus. So 1 minus 0 over 0 squared plus 1. And so we get an initial velocity of 1. Now they don't give us the units, but we know that this is going to be in distance over time. Okay? And that's it. So again, just practice these, and the more you practice, the easier these become. Have a great day.